Oh, this does actually work. So actually, at the moment, there's two ways you could do this. You could go 8 plus 8 is 16. 16 times 4 is 64. Oh, wait, no, that doesn't work. So let's try again. So this is an 8 by itself. We do the multiplication first, which gets us to 32 divided by 2, and then 8 plus 16 is 24. Well done. You have won the lottery here. Okay, guys, we are going to get going now. Well done to all of you who participated in the early warm-ups, but we're going to start our lesson. And yeah, please do try and come early in future because we have a lot of fun just before the lesson, and we'd love to hear from you before the lesson and just get a sense of how you're feeling. So just some things we're going to try out today is we encourage students always to find a clear space where they can kind of work without distraction. And then we also, today what we're going to do, we're going to try something new. We are going to basically mute learners for the first 15 minutes or so. And in that time, if you are having issues or if you have questions, what's going to happen is Miss Anya is going to be monitoring the chat stream, and then she will then ask one of you who's basically raised a question, would you be willing to say it out loud? But don't be surprised if you find that for the first 15 minutes or so, you can only use the chat stream. So we just want to do a little experiment and see if you can use the chat stream to voice your questions, at least for the first 15 minutes, and then we will open it up for audio for questions that are representative of the group. But please do use the chat stream nicely today. Okay, so what is the focus of today? Well, let's do our admin and announcements. So the first thing, before I hand over to Ms. Anya for this announcement, is that at about 5:45 today, on Wednesdays, we do like a fun end of week quiz just to give you some feedback. And so at 5:45, we will share a link with you, and that link will take you to a quiz. And that quiz, after you've finished, you'll be done with today's lesson. So when you leave me and go off to do the quiz, you won't have to come back again. Basically, when you finish the quiz, you finish the lesson for the day. Okay, so that's just coming up later in the lesson. And then, Anya, if you want to just take students through an announcement from Watobe on the admin side, I'll hand over to you and just zoom in so that they can all see, and I'll highlight as you're talking.
Okay, guys, listen up. This is a very important announcement. So if you're on the second week of your free trial, in other words, you started your free trial last week, then your parent will receive a WhatsApp message from us in the coming days with a payment link. So the free trial is only for 2 weeks, and then they should get a WhatsApp in the next few days with payment details if they want to continue. Then just on that, if you find Watobe classes to be useful and helpful, please, please, please tell your parents tonight that you want to continue with the program. Otherwise, you want to work with us. So they know this when we send them the payment request. Otherwise, I think just paying for nothing. Right. So please, if you love attending these lessons and you want to keep attending them, you have to ask your parents very nicely for this. Right. I'll hand back to Sir.
And then the other thing to realize is that if you only started your free trial, let's say last week, or let's say you're only 1 week in, or you just started your free trial today, then you won't receive that message yet. So this only applies to people who've had sort of 2 weeks and you've had a chance to get a sense of what's going on. Okay, cool. Let's get to the maths. So I want to do a quick little recap of the last lesson. And in the last lesson, we were dealing with something called BODMAS. And the main idea behind BODMAS is that certain operations have to be done before others. And so we have these groups that we use. So brackets are always first, and exponents, they on the first group. Then we have division and multiplication, and then we have addition and subtraction. And we were using these to help us know what to do if we have something like a number sentence or an expression like this. So for example, in this expression, there are 3 operations, but the operations that get done first are these ones over here, because they are, multiplication is of a higher precedence than addition, which is, further down the list. So if we were evaluating this, we would get 16 plus 15, and then in the last step, we would get 31. Okay, so that is one of the main ideas we were dealing with. And then we also dealt with the idea of factorizing, or actually we dealt with rounding. And there was a little bit of confusion with rounding. So I just want to show you kind of how the concept of rounding works. I've got some examples here. If I want to round to the nearest, I'm going to ignore this one. I'm going to go straight for this one over here. If I want to round to the nearest 1,000, I have to go to my number, and then I have to ask myself, where is the thousandths place? So the first one is units, then it's tens, then it's hundreds, and then it's thousands. So now, how do we round this number off to the nearest 1,000? Do we look at the thousands place? No. We actually look at the hundreds place, which is just below the thousands place. And because this number is a 3, this thing is going to round off to 142,000.
Sorry, sir, can you just zoom in a little bit more for us, please?
Okay. Is that a bit better?
That should work for you. Yes.
So in this case, because we're looking at the thousands place, which is over here, but in order to round off, we actually need to carry out the rounding. We need to look at the one below that, which in this case is the hundreds place. And because the number in the hundreds place is below 5, then all of these become zeros and we round off to 142,000. Now, I just want to give a little bit of a chance for everybody to do, let's do these ones. So I want you to try and do that one and that one. And then I also want you to do this one and this one. But the difference is in the second question, you're rounding off to the nearest 10,000. And I just want to make sure, we picked up in the last lesson, some people weren't absolutely certain on rounding. And so let's just do a little brush up. And then once you've got your answer, could you please put it in the chat so that Ms. Anya can see it, and then we'll get a feel for how the rounding is going. So if you do round, the ones with ticks are the ones we're doing.
Yes, Anati, you can post your answer right in the chat for us, please.
And I'll even write, I'm going to give you like labels. So you can say your answer for A, B, C, and D. And if you could just say, what do you get for the answer for A? What do you get for B, for C, and for D?
And just on that note, for A and B, it's to the nearest 1,000. For C and D, it's to the nearest 10,000. Just make notes of that, please, and check which numbers you are working with.
Perfect. Yeah. Okay. So the nearest 1,000, let's have a look. Where am I going to look? I think Anya, I think there's something about when I hit the pen thing twice that somehow it stops.
Okay.
I must just be careful of double tapping. So
just on that note, while Sir works it out, remember, when we ask for the nearest 1,000, you actually look at the hundreds. If I'm asking for the nearest 100, you actually look at the tens. You always look at the one value to the right of where you actually are.
Yeah, exactly. I'm using my teacher powers. I'm adding an extra question and we're going to do E as well, and we're going to do an F for this one over here, because I feel like this is good practice. So for this one, we're looking at that, we should get 356. Now it's not 6 because the next one is a 5, so it goes up. So we get 35700. 357,000 is that rounded off. Okay, now let's have a look at, okay, I'll give you a little bit more time. How are the answers starting to come in the chat there, Anya?
Yeah, we've got quite a few A's, we've got B's, we've got C's, we've got D's. Do you want the students to also do E and F?
Please do E and F as well. So if you, hopefully on the screen, I've added 2 more questions, E and F. I will start to put the answers up for this one. So now it's 10,000, which means I actually have to look and first find where is 10,000's place. So that's 10,000 is there, which means that I'm looking at the number next to it, which is a 2, which is going to mean when I'm rounding off, I get 140. It's staying where it is. So 142. No, I need to actually look. Where am I? 142,000. So that's 2,000. It's to the nearest 10,000. It's going to be 100 and I'm looking at the wrong place. There we go. So that is thousands.
Ted, we're going to take questions a bit later. Do you mind just lowering your hand? I'll see your hand and we have an opportunity to ask questions. I'll send the mic off to your side. Okay.
So you should get 140,000 for that one. And then for the next one, you should get 340,000 for that one. And then for the next one, for E, you should get to the nearest 1,000. So it's 100,000. And then for the nearest 10,000 for this one is also going to be 100,000. Okay. Can you give us a thumbs up if you're feeling okay with rounding, and a thumbs down if you're like, oh, this rounding thing, man. So thumbs up if you have, and thumbs down. Oh, I love that. I can see some of your video feeds and your thumbs up. It's great to see you guys. Fantastic. Okay. Always good to keep practicing rounding. It'll come up in estimation and a bunch of things. So what I also want to talk about is in the last lesson, sorry if I'm making you dizzy, we started talking about something called factors. And so I want to start the lesson, I know we were talking about the ladder method, but I just want to talk about identifying a whole list of factors. And what I said in the lesson was the numbers, each number has its own factors, the numbers that divide something exactly. And so I want to show you how we can list some of the factors. So for example, for the number 36, the first 2 factors that I can list are 1 and 36 because 1 divides 36 exactly. Then I could go along and go 2 is 1 factor of 36. Now, what is going to be the matching factor for 2 that goes with it? Can you put it in the chat? So
sorry, sir, can you just zoom in again? I think for these, I think you have to show like 2 or 3 numbers at a time. Yeah, I think that'll be a bit better.
Okay. So what I'm doing is I'm listing the factors of this number. So what is a factor? We started in the last lesson. It's a number that divides a number exactly. And so often when we list factors, we list them in pairs. So the pair of factors 1 and 36 go together because 1 times 36 is 36. What would go with the number 2? And I'd love to see the chat stream. if you could list, and could you list other pairs of factors? What other pairs of numbers are factors of 36? I see Kenneth has the answer coming in. Kenneth, you are on the money. So 2 and 18 are a factor pair. I'd love some other factor pairs that basically go together that we know are factors of 36.
Sir,
Yeah.
should we put in the factor of 36?
Yes, you should.
Can I give the next one?
Yes, please do.
3.
So 3. Okay. Now, can we have someone in the chat respond? What is the matching factor that goes with 3? Oh, I see some more coming through. 4. But what I want to know, what's the one that matches with 3? Ah, I see that Robetswe has got it. It's 12. And then the other factor was 6. So if we look at the number 36, let's try and count how many factors it has. It has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 factors, and most of them occur in pairs except for 6, which is kind of its own pair. So those are the factors of 36. Now I want you to find me the factors, and I want you to do this in a list. You're going to do this. I want you to find me, we'll call this for B, C, yeah. I want you guys to do all of these. I want you to list for me the factors for each of them. So what are the factors of 37? And what you'll do is in the chat, you'll put B, and then you'll just put a list for B. You'll do C, and you put a list for C in the chat. So I want you to try and figure those out. I'm going to give you about 3 minutes on the clock to do that.
So while they do that, I just want to also just reiterate to them, guys, when you do fractions and your factors, and you can see my screen hopefully, try to think of it as peeling an onion. So you start on the outside first. You first take the outside layer off. Once you've got the first layer off, then you do your second layer, third layer, fourth layer, until you're right in the middle. Then when you have your whole list, you can share your list in the chat, if that makes sense. Right.
Yeah.
And then, sir, while we're at that, I see a few students have tried to raise their hands. So when you are ready a bit later, you must just open the board for chat. All right.
Well, I think what we can do is, while students are busy getting all the factors for A to E, let's open the mics so that if any students want to ask questions, that's possible. And then whilst those questions are being asked, other students can carry on working. Okay.
Okay, let's do that. Right. Yeah. You guys are welcome. If you want to stay muted, that's fine. But if you want to share something, now's your opportunity to unmute. I think if you want to ask a question, even if you're unmuted, I think just raise your hand so it's not like a wave coming in, maybe.
Yeah. Okay, Trevor, I see that hand. How can we help you? Or what's your question?
Isn't like 9 and also a factor for 36?
Isn't 9 also a factor for the 36? I think you have absolutely got it. Let's have a look. So if I go 36 divided by 9, 9, 18, 27, 36, you know what? 9 and 4 are matching partners, which means that 1, 2, 3, 4, 5, 6, 7, 8, 9. You are on the money, Trevor. You are on the money. Well spotted. There are a lot. 36 has a lot of factors. Well done. Now for B, all I've got so far is 1 in 37. Yeah, Kumo, go ahead.
Sir, I wanted to ask about the ladder method.
Yes, we're going to do the ladder method in the next step. So we're just going to do this first, and then I'm going to talk to you about the ladder method.
Okay.
Cool. I just want to make sure everybody's comfortable with factors, and then we'll go from there. So 438, you're right, we have 1 and 38, and then we have 2 and we have 19. So I see 2 factors here, and I see 4 factors here. What about 39? Okay, 10 has Oh, 40 is lots. For 39, I have 1 and 39. What else do I have? Lesego has got it. It is 3 and 13. And that is the only factors that I can see. And then for 40, there are lots of them for 40, because 40 has lots of different things. Let's have a look. And I see Kenneth has listed a lot of them. So there's 1 and 40. There's 2 and 20. What else do we have? We have 4 and 10. I'm running out of space. Then we have 5 and we have 8. And I think that is it. So 1, 2, 3, 4, 5, 6, 7, 8 factors. Okay, now what I want to do is just show you how some numbers have lots of factors and some numbers have a couple, and some of them only have 2. In this list of numbers that we've got here, we would say that 37 is a prime number because it has only 2 factors. Okay. Everything else here is going to be what's called a composite number because it has more than 2 factors. And in the lesson today, when we do the ladder method, the prime numbers are going to be particularly important when we break things down and we use something called the ladder method. Now, I want to ask you, if you compare 36 and 40, so 36 and 40 are the 2 ones that have the most factors. I want you to look at the list and look for the highest factor that they both have. In mathematics, we would call this the highest common factor, or the HCF. I want you to find for me the HCF for 36 and 40. And I want you to put it in the chat. So what is the factor that's in common, the biggest factor that's in common to both? And I want you to list it in the chat.
We've got a few answers here. We've got Sonata and Lesedi have agreed on 4. Tumelo says it's 38.
Okay. So what I'm going to say is, if I look at this list, the first number that's in common to both is 2. Now, 2 is a common factor for both these numbers. 3 is not. 4 is a common factor for both numbers. After that point, I don't see anything here that's in common with anything here. So for me, I think the highest common factor must be 4. So one of the ideas that I want you to understand today is, if I have 2 numbers and they all have factors, if I ask you for the highest common factor, then you need to look for the biggest number, the biggest factor that's in common to both. Now, we did this the slow way because I wanted you to get a little bit frustrated so that when I show you the easy way, you'll really, really like it and listen to it. So give me a thumbs up if you think this took a long time. Give me a thumbs down if you think this way was easy. So thumbs up if you think this took a long time. Thumbs down if you think it was easy. Okay, there's a mixture. So I'm just going to zoom out for a second, and I'm just going to focus on 36 and 40. Okay. Now, we can use another method called the ladder method to figure out what the highest common factor was. And that's what I'm going to do with you now. So we know the answer to this question, right? We know that the highest common factor of these 2 numbers is 36 and 40. But I'm going to show you a different way of doing it. And I started in the previous lesson. So you start by drawing a number, basically a ladder around the numbers that you're comparing. And then you ask yourself, you say, if I had to take the smallest prime number that there is, check which is going to be 2. How many times does 2 go into 36? Well, it basically goes in there 18 times. Okay. Now ask yourself, can 2 still divide that further? And then we'll say 2 divided by 18 is 9.
9.
Then we ask ourselves, can 2 still go into 9? No. What's the next prime number that may be able to divide this? It's 3. So how many times does 3 go into 9? It goes 3 times. And now we ask ourselves, does 3 go into 3 again? And we say yes, and we get 1. If we use this method, we can see that 36 can be written as 2 times 2 times 3 times 3. And this is called the prime factorization of 36. Now, I want to give you a chance to do this for 40 now. So I'm going to start you off, and I want you to think, okay, let me take 40. I'm going to try and do the same process. And I start with the smallest prime number, which is 2, and ask myself, how many times is it going to 40? And it's going to go 20 times. And I want to give you a minute to see if you can figure out the rest of the ladder. And then I'm going to show you something.
So while we're doing that, I see we've got 2 hands in the choir. I've tried to reach them out to the chat. We've got Yandisa's got a question, and then after it's Murdy.
Okay, go ahead.
Yandisa, you can ask your question, just unmute yourself.
Yes, ma'am. Sir, I was asking, so when you're saying that you were doing the, what is it called again?
The ladder method?
Yes, so the ladder method. So, sir, my ladder method is kind of different. It's not like the way you did it.
Okay, it's fine.
So let's say you remove.
Yeah.
Oh yeah, so like it's like a factor tree, you see, sir.
Yeah, it's fine.
Where
Absolutely
you write,
fine.
oh.
So all you would do is you would start by doing this. I'm going with the ladder method because I think it's a little bit simpler, but if you get the same answer, you can use the factor tree method as well. Really not a problem.
Yes, sir.
Perfect. Other question?
Murdy, and then after Murdy, it's Kumo. Murdy, can you hear us?
Okay. Kumo?
Sir, I also wanted to ask if you could use the factor tree, or must you use the ladder method?
You can use either of them. As long as you get to the correct answer at the end, it's completely fine. So the tree method is perfect. Now, let me show you why I think the ladder method is so cool. If you followed my kind of process, I took 40 divided by 2, I got 20. Then I took 20 divided by 2, I got 10. And I could see I could still divide by 2. And then I got to 5. And then I said to myself, well, what's the next prime number after that? It's 3. Does 3 go into 5? No. So I left 3 off the radar. Then I said, what's the next prime number after 3? It's 5. Okay. Does 5 go into 5? Yes. And so that's why I wrote it over here. And then I said to myself, oh, okay, well, now I've got down to 1. Now, what that means is that this bit over here, these are the prime factors of the number that we started with, which was 40. Now, let me show you how we can use this. If I write 40 out now as a product of the prime factors, so 2 times 2 times 2 times 5, I can see what is in common to both. So what I can visually see now is I can see they both have a 2 in common, but they both have another 2 in common. Now, they don't have a third 2 in common. That is different. There's no third 2. They don't both have 3s. They don't both have 5s. So by doing this and comparing them, I can quickly see the highest common factor here is going to be 4, which is the same answer that we got from the earlier way, except the earlier way just took a lot longer. And you may say to yourself, listen, teacher, that actually took a really long time as well. Well, when the numbers get bigger, this method of finding the highest common factor is much easier. And so I want to show you a slightly harder question where we can use this approach. So just to highlight the approach was I gave you two numbers, 36 and 40, and you broke them down into their prime factors. You then used their prime factors to find the highest common factor. And so we're going to do another one of those where we test out what you've learned in the first part. Oh, sorry, guys. My computer is running away from me. Let me get this. Okay. So I want you to do the following. I want you to find for me the highest common factor of A and B. The first one, you don't need to use the ladder method. The second one, I want you to either use the ladder or the tree method, for those of you who have learned that. And I want you to try and find me the highest common factor. And then if you're really on fire, if you are like smashing this out of the gate today, you can have a go at E. Give me a thumbs up if you understand. Yep.
Okay, perfect. You zoomed in. And then, sorry, sir, while the kids are doing that, can we please give Ted an opportunity to ask his question?
Yep. Go ahead, Ted.
So we can do these things in any ways as long as we get the correct answers.
Yeah. So the main principle, Ted, is I'm teaching you how all numbers can be broken down into factors. So that's what I was kind of showing you in the first part of the lesson. And now I'm showing you that even those factors, they can be broken down into the smallest pieces of what's called the prime factors. So every number can be broken down into its own little building blocks, and they're called the most important ones are prime factors. And when we break numbers down into their prime factors, it's very easy to see things like the highest common factor and stuff like that. Now, in A, I've already written them in terms of their prime factors. So you just have to look and see which things are in common. But all these numbers that are being multiplied are all prime numbers. Notice that there's no 3, there's no 6. So this is already a prime factorization. What you need to figure out is what is the highest common factor for both of those. And once you've done it, put the answer in the chat. The second one is a bit harder, and then E is quite a bit harder. But that's only for when you've done A and B.
Sir,
yeah.
Just to help our students, do you mind doing number C with them?
I can do C. Okay. Let me have a look. Okay. Well, let's do A, and then I'll do C, and I'll leave B for you.
Perfect.
So for A, what I see is that there is a 2 in common to both. There's no more 2s in common. Are there 5s in common to both? No. So there's no more. This one is not relevant. 5s not in common. Are there 7s in common? Yes. 7, 7, 7, 7. Are there 11s in common? Yes. Are there 17s in common? No. Okay. What I found here is that all the things that are in yellow are in common to both of these numbers. And so the highest common factor for A is just going to be 2 times 7 times 7. Ooh, 2 times 7 times 7 times, what's the last one? It's 11.
11.
Now, you can even use your calculator for that number if you want. You know, it's going to be 14 times 77. And then you can go through that process. But essentially, this is going to be, in fact, let me use my...
The final answer is 154. So it's 2 times, oh, sorry, I typed wrong. My apologies. 2 times 7 times 7. Sorry, it's 1078. Okay, so which is quite a big number. So this is the highest common factor. Now, that was maybe a little bit hard, but let's do C together.
if we look at the number 8 and we look at the number 12, let's use the ladder method on this one, just because it helps build the capacity. The first prime number I'm going to use is 2. And does 2 divide into 8? Yes, you get 4. Now, let's try 2 again. Does 2 divide into 4? Yes, you get 2. Does 2 go into 2? It does. Does 2 divide 2? You get 1. And so we know that 8 is actually the same as writing 2 times 2 times 2. Let's try this for 12. Does 2 divide into 12? Is 2 a factor of 12? Yes. And if I divide 2 into 12, I get 6. Can I do that again? Yes. I get 3 this time. Can I still divide 2 into 3? No. Can I divide 3 into 3, which is the next prime number? Yes. Notice how I'm only dividing by prime numbers on the left-hand side, and notice how I always go until I get to 1. Now, the bit on the ladder tells us what the prime factorization of the number was. It was 2 times 2 times 3. The question in this case is the highest common factor. Now, the highest common factor, they both have a 2 in common. They both have another 2 in common. They don't have the final 2 and 3 in common. So for C, we're going to get the highest common factor is going to be 4. And a lot of you will be able to do that automatically, right? So you'll be able to do that just by looking at it. But once you get to B and E, it gets a little bit harder. So give me a thumbs up if you feel comfortable giving this a go now, and give me a thumbs down if you still feel very confused in the chat. So thumbs up if you feel, okay, I sort of know where this man is going. Thumbs down if you're like, ish, I'm still a bit confused.
I think so. While the kids are putting their thumbs up and down, what I'm seeing in the chat is the kids are fine with working out like the ladder or the tree method. In other words, writing a number in product of prime numbers. But I think they struggle a bit from what I'm seeing with the final step of actually comparing the two sets of numbers.
Okay, fair enough. What I would say is why don't we, okay, I'm going to ask you, if we look at B, step 1 would be to write, the goal here is to find the highest common factor. Now, I think a lot of you kind of have some ideas already about what that is, but I need to show you a method. So the method is, I write the 24 in a ladder, I write the 40 in a ladder. And so really it's this last step. Let me do B with you, and then we'll all try and do E together, and we'll finish with that today, because I think that is a little bit sneaky. So I'm going to start with dividing by 2 again, and I get 12. Let me get rid of some of this distracting stuff. Okay, I'll give you a minute. Why don't you try and do the ladder? Let me not steal all the joy from this. Try and do your ladder quickly. Try and get the answer, and then I will come along and give you the answer. But I want you to actually attempt it first. So what's the highest common factor of 24 and 40? And you have to use the ladder method for breaking it down.
So I think just to make life easier for you guys, step 1 is first do the tree or ladder or whatever method you choose to work out the prime numbers or product of prime numbers for each number. And then we get to the fast. So what Sir's doing on the screen of writing the ladders, we first do that for both numbers, and we first calculate those. That's step 1.
Agreed. So what I think you were saying is students are getting confused at is, how do I go from this ladder to get the highest common factor of these numbers? And so you could look at the ladder. You could say, what do both these ladders have in common? And in this case, that's all I would see. I don't see, oh wait, no, I lie.
Two as well, yes, that's correct.
Now, I'm not sure, some students would benefit from writing this out in full and seeing it like this. Some students will be completely comfortable just doing it from the ladder. But basically what I want to show you is that both of these numbers have 2 times 2 times 2 in common. And so the highest common factor for this one is going to be 8. Because 2 times 2 times 2 is 8. Now let's see, let's test this. What does 8 divide 24 exactly? So 24 divided by 8 is 3. What is 40 divided by 8? 40 divided by 8, 8, 16, 24, 32, 40, it's 5. So we can see that 8 is indeed a common factor, and it's the highest common factor. Okay, last question for factors for the day. I know I'm pushing you now, but I want you to try and find me the highest common factor for these two numbers. Now, notice how huge this is. If we had to do it the long way and try and write out all the factors, it would take us long time. But because we've learned this new method might help us. So let's start by doing this. And then let's start by, can you figure out what's called the prime factorization? And I want you to try and complete the ladders. I'm going to take a break, and you are going to do this for the next three minutes or so. And then we're going to go till 10:02 today, because I think we need that little bit extra time. We can switch over easily. So
yeah.
All right, students, it's your time to shine. Do the best you can in working out the factorization of this, and then trying to get to the highest common factor of these two numbers. And I'm going to grab some water.
Whilst Sir's grabbing some water, Murdy, I see your hand is up. You're welcome to ask your question. Just there with Maria's answer, just check if the HCF, ask yourself, can, for instance, 49, oh, she's changed it now. Always check if your number can then divide into both numbers as well, okay? Because that, if it doesn't, then that should be a red flag as well.
Murdy, I see your hand is raised. Do you want to go ahead? Murdy, any questions? So I wonder, how many times does 3 go into 105, or does it go into 105? Well, I know 3 goes into 90. So 93, 96, 99, 102, 105. So I think that 3 goes into 105 35 times. And then I get stuck again, because does 3 go into 35? No. So I need to use the next prime number, which I'll let you do. Now, what do I do on this side? I think 14 can be divided by 2. That gives me 7. And can you finish it off from there? And can you find me my highest common factor? That would be awesome. So 3 wouldn't go into 7. 5 wouldn't go into 7. Oh, but the next prime number is 7. And so 56 is just going to be 2 times 2 times 2 times 7. Now, what about 35? Oh, what's the next prime number after 3? It's 5. And how many times does 5 go into 35? I think it goes 7 times. Now, I still haven't got to 1. So 5 doesn't go into 7, but the next prime number that goes into 7 is 7. And so I get that. Okay, so now I've got my prime factorization on the left-hand side here. And I've also got my prime factorization on this side. In order to find the highest common factor, I need to find factors that are in common to both. I'd love to see if any of you know the answer from this step, if you could put it in the chat. So I see 2's in common. I see no 3's in common. I see no 5's in common. I do see 7's in common. And another way to see this is 210 is 2 times 3 times 5 times 7. And 56 is 2 times 2 times 2 times 7. Both of these seem to have a 2 and a 7 in common. And so my highest common factor is going to be 14. Don't know if anyone got that. But the highest common factor here is going to be 14. Is it right? Wait, am I making things up here?
Yes, that's quite right, sir.
Okay, guys, that was actually quite tough. And so we will continue with this in the next lesson. So if you're feeling a little bit, this is tough, don't worry, the lesson will continue next time. We're going to ask you to do a fun quiz now. There will be a little bit about something called multiples in the fun quiz. And so I just want to see what you guys know about multiples. I know we haven't spoken about it too much yet, but multiples are in the same kind of area of mathematics as they're in this section as well. So we're going to finish the lesson now, but you are going to go off and do a quiz for me for fun, just to give us a sense of how things are going. Now, Ms. Anya is going to put the link to the quiz in the chat, and the quiz will take probably about 10 minutes to do, maybe 10 to 13 minutes or so. And once you're done with the quiz, you are done for the day. I'm going to jump off because I am just going to go to my grade 11 lesson, but I will leave you in the capable hands of Ms. Anya. I just want to say well done, guys. The fact that you're here and you're putting in place good habits this early in the year is something that is, really fantastic. And I look forward to working with you on Monday. And enjoy the quiz. Let me know how it goes. So bye for now. And then Anya, I will see you in grade 11 in a minute or a couple of minutes. Thanks so much for your help. It was fantastic having you giving inputs as we went.
Perfect. Thank you, sir. See you now.